we use what's known as urea. There's a big white tank over in the corner, and we get deliveries about every two weeks. It burns a few gallons a day. That thing holds about 400 gallons. But what it is it's a scrubber that gets injected right over here with a Miratech right on the wall there. There's a pneumatic-driven pumping system, and there's stainless steel tubes that go into the exhaust stream before the catalytic converter. And what that does is it injects and atomizes urea. And I know you'll laugh at this, but if you don't know what urea is, it's basically refined pig urine. That's what it is. And it goes into the airstream, and it knocks down all the hard particulates that are in exhaust air. And when the exhaust is coming out of that stack, it's relatively like 97% clean. It's really, really clean. That's what makes it environmentally sound.
Do you even understand?
I don't know how they measure it, to be honest with you. We have to
Because the size is small, I don't know. The power plant,
I don't.
unit regulations how much particulate goes in the air.
So we have ways of measuring levels, yes, but I don't really pay attention to it. They just have that data log, so that if they do get called in to an audit, they'll have the information. We have to make sure that that tank never runs dry. When it gets to be about 150 gallons, we call and they come with a big tanker. They pull in usually at 6 a.m. because this parking lot's a little tight. They have to pull up alongside the building. They pump it in. It takes about a half hour to fill that tank, close it up, and off they go. And we just watch the level. That's one of the readings that we have to do every single day. Because if it gets down below 150, you run the risk of it going dry. But even when we have had issues with it running out, our air quality is still like 92%. It's still clean. Relatively clean.
It's driving natural gas.
Yes, yes.
The city wouldn't let them run the diesel.
No.
Can you show them the experience of this guy on the side?
Yeah, you guys want
One more
to
thing, you see that those guys, come over here, you can go inside. You can go inside. Guys, yeah, you guys come over, you go over there, and then you come inside. Oh, make sure you don't touch those switches. Yeah, guys, go over there. We go in there.
So this screen here, if you didn't see it already, this is how we start and stop the machine, and it gives us some generic overview on what the machine's doing. This is how I start it once every quarter. All right. For those of you that might not have heard me, this screen here is pretty much how we start and stop, and it gives us a little bit of monitoring potential. Okay, it's just a screen that we start off in, but a lot of times I'll go down to the engineering screen, which is this screen right here, which you may have seen before. This screen tells us any alarms that come in. It helps us troubleshoot and diagnose, but it also tells us a lot of temperature and pressure, steam pressure, the pounds per hour. I told you it's around 16, right now it's 1638. The boiler pressure 12.1 pounds. It tells us through here whether we're dumping to the cooling tower or whether we're putting the back pressure on and going up through the stack. It tells us a lot of things. It's a great screen. That screen in conjunction with the next one that I'm going to show you is how I figured out that we were going to lose a cylinder. But this engine data here, this is pretty much just the engine, and it looks at the cylinders, it looks at different water temperatures, water pressures that are important to that, keeping everything cool. We actually use 600 degrees. We use about 300 degrees to cool that engine. So that engine is running at about 300 degrees hot, but it still is cooling that engine down. So we send water through from our boiler plant. That boiler water actually takes about 300 degrees off that engine and cools it down. And at 300 pounds under pressure, it won't boil off as steam. So steam is 212, right? So when you pressurize anything, the boiler, the steam effect, it takes a lot more heat to create steam under a higher pressure. So, but anyway, so that's the engine. And then we have another screen which
What do you mean the red color, green color?
The colors?
Uh-huh.
You're talking about the red and green? Is that what you're talking about?
Yeah.
So,
The green and green. What is red and green? What do you mean?
what does the red and green mean? Whether it's running the way it needs to or not. But the funny thing about that screen is, it's not consistent. So,
Oh.
yeah, so you actually have to look at the data
Oh,
associated. The color, they did a terrible job. Like red means stop and green means go, right?
Yeah.
That's the way you think, but they don't do things conventionally here. They, engineers think like engineers and maintenance people think like maintenance people. And when you first look at a red and green, you think it's stop and go.
Yeah.
Okay, on, off.
Mhm.
In alarm, not in alarm. That's not quite reflective of what we're looking for.
Okay.
So you really have to look more at the content than you do the color. The color was just a bad choice. It could have been pink and blue for, it could have been anything.
Yeah.
But this screen here shows all the thermal data, anything about the temperatures and pressures of the engine, the exhaust. You can see the temperatures of the exhaust, 746. And then you can see what's going in, and then you can also, we used to be able to see what's going out. And to me, not having that temperature going to the roof, they really messed up on that one. They should have kept that temperature point because
This is what thermal.
what's that?
Thermal gun here. This is.
Yep. Does anyone have any questions about this stuff? Generally speaking, when I come in to do my readings in the morning, it takes about a half hour. And then tonight, the night guy that's here, he works until 10:30. About 7 o'clock, he'll come in after dinner and he'll do another set of readings. And then when I come in the morning, I'll compare what I see and what he had. If I start to see anything, I'll flag it and I'll let people know. This is coming up on an oil change. This is going to be due for an oil change or an overhaul. So I think next week we might be shutting this thing down to at least change the oil. Changing the oil, it should be a couple of hours. If they have to do an overhaul, it's a few days. They've got to literally get in and tear the engine down. Anybody have any questions? No? If you guys want, you can go in. I would recommend putting in some hearing protection. If you want to go and take pictures, please don't go upstairs. It's safe.
Where's the heading down?
What?
No, and then you can ask question over there. It's quieter. But these are the soundproof.
We're gonna go in the chiller room now.
Chiller room. Yeah, go. The chiller are not working. It's not a season. So be quiet.
The water to get through.
See the guys. This one is the new unit. This was the older unit. This was a new unit. There was an absorption machine here. But guys, let Brian come through. Let Brian come through.
Part of it. It's a lot of complicated. Alright, so, well that's for Lufkin. We're renovating Lufkin. We're putting chill water plant for all of them. Blumenstein, 2A. What you have in this room is the chillers. This is where all the cooling is made for the main campus. Again, we send chilled water through the tunnels all the way over to Washington, and we send it up the piles, the top floors of Williston. Up in Williston, there's some air handlers with chilled water coils. We send it to variable air volume systems. Ductwork, we send say 62 air. Depends on what the flow is outside, determines what we run the cooling at. But what you have behind me are two 600-ton each, so there's 1,200 tons of capacity. So picture a standard window unit in your house at 12,000 BTUs. This is the equivalent of 1,200 window air conditioners. So how many windows are right there? A lot. We used to have window air conditioners everywhere. Way back when I started, a lot of this place was cooled through window air conditioning. And the efficiency of this compared to window air conditioning? It's all about the voltage and the amperage. So on anything, the higher the voltage, the lower the amperage. But it costs you a lot more money to run the wire for things like that and to transmit the power. But a higher voltage is a lower amperage. These are 480 volt machines. So uniphase, and what they do is they produce 600 tons. Now we don't use more than 600 tons right now, but we've got redundancy in case one should go down or need to be serviced. We have the redundancy so that we can run either or. So we're not spending the campus is not spending any money on it. Oh yeah, they are. They spend money no matter how you slice it, because the main campus, like right now, we are using mechanical cooling because the outside temperature's got above a certain dew point. We run it off of a temperature and dew point relationship. Yeah, humidity is the key. So when humidity is high, you may not have enough in what's behind you with the free cooling. Now this unit right behind Professor Zanuzzi, that's a plate frame heat exchanger. That is 100 tons. So that little plate frame can do 1/6 of what this entire chiller can do.
Less than a footprint.
Right, but it's also not extremely reliable. It can't run when conditions are too cold. You follow what I mean? We run water down from the cooling towers on the roof, and we reverse the water. We actually take the cold energy from outside air in the winter, and we run it into here to chill the water, which is the chilled water that we would typically manufacture through a refrigeration and through electric compression.
Where do you have a
cooling.
Where do you have a cooling load in the winter?
Where do we what?
Where do you have a cooling load in the winter?
Oh, right now?
No, in winter, usually.
It goes over to CEIS, it goes up to the main air handler if needed, and it goes over to Beatty Hall.
No, right now, yeah, but in the winter?
In the winter, it will still go over there, yes. Because there's air handlers over there that are trying to discharge a certain air temperature. And you can't always get that through outside air. So, yeah. But we run our cooling year round. The chillers may not
But that chiller is running, guys. If you want to look at it, that chiller is running. Go look at the...
Yeah, this chiller
look at
right
the
now
board.
is
If you
running.
want to look at it, go, that chiller is working. No, on the left side, left side.
Run the cooling tower at about 78 degrees. And that dispels the heat, puts it back down, and sends the water back out of the thing.
No, shit, it's stuck.
Huh?
It's in itself. Push it. It's stuck.
It's good.
Right there, that is how we load the pumps. For the cooling, for the chiller, so water pumps. Huh? Water is loaded with? It's all water, it's straight water, no glycol. Still? No, not the still. It's water, But if we ever have to service any of the pumps for the cooling tower or the chilled water, we have to raise and lower them through this hatch. They each weigh about maybe 8 to 900 pounds. Wow, you got something over there that you device in here? Well, we can bring one in. We don't need it permanently because it's just cumbersome. So we would have to get the pump over to this area, and they're all 6 of them are set up in a row, right up here in the code den.
Guys. Yeah, okay, sorry.
We open that up, service and bring them in and out.
So these are mechanically controlled solenoid valves up here?
No, those aren't.
Those aren't solenoid valves right
No,
there?
they're
Those
not.
are
Those
sensors.
are probes.
That right there, is that a...
That's not automated. This is automated right here. And it just gets a signal to open and close.
Is that a gate valve?
Huh?
Is that a gate valve? No problem.
Anyone have any?
Guys, do you know how they put this one here? This is new. Look at see. You get to see. And they open it when they came here.
So,
when they were
what? Seal it out? Or is it all...
They put those, there was a like a main program. Main program, they had that kind of gas.
Oh, so the glass apron is no longer there?
Yeah, where is that?
Oh, it looked cool, but it wasn't...
Now, one of the things too that you have to understand with these chillers in particular, the refrigerant is 134 days. It's extremely toxic if you were to inhale it.
Yeah.
So we have a system that senses, and it is a leak on it. It's sound alarm to evacuate this area and then come on and vent it out. They get killed. Okay, so
Most
we gotta leave-
refrigerants can.
Well, no, not all of them, but this one in particular needed, so we have a
Ammonia is
system.
worse than this, but it's still this one.
And I made the mistake one day of spraying an aerosol chemical on a nut and a bolt.
And it triggered the alarm?
It triggered the alarm. It showed you, and I did not spray much, it was very, very slight, and it picked it up way over there.
Oh, we did it some.
Yeah, yeah.
Well, the second it detects anything, that leak could get back at any
Well,
point.
it's certain products, certain things.
If that alarm picked it up and it's only sensing that chemical, hell, I should have used that chemical indoors.
Guys, a question about the chillers.
Does anyone have any questions?
About the chillers, so you produce the chilled water, send it to air handling unit.
Are there any plans to explain?
You blow the air over the chilled water, chilled coil, so that's what the central air is for each different of it. So
Are there any plans
It's
to
a plan,
expand
and you need to put it in Bangladesh.
This is only 540 kilowatt, right? In my the plant I work in, the backup generator was 2 megawatt. That was the backup generator. The main generator is
big.
yeah, it's 135 megawatt.
How many for population?
That is for one steel industry, not for population, not for home.
I know.
It's for one steel industry.
So just the city.
Yeah, not for other city.
In the big city.
Not the city. It's the industry factory.
Oh, in the big city.
We also have two tabs on the bottom. That is in case you want to have a third chiller. This is actually a capacity for whatever you need to, upgrades to different parts of the services or the building. They have the ability to
Yes,
take off
maybe
here and here, and they can put a third chiller overhead. So that you can put your head in here and have a third chiller. They may, but they know what, they've already got it engineered.
They,
They want it.
they make melt the metal. That's why they need more heat.
There's room in there to act as the second cogen right beside it.
So, this is the power plant overall for the emergency money or cost of emergency money?
Well, it doesn't, see, you're gonna have maintenance
Yeah, it
costs no matter
depends.
what.
Do you know actually how much they get back from the they send it to the grid?
I know what the effect really is reduced,
not reversible.
it's reduced electric rates is what it winds up being. So when we sell back to the grid, we're able to acquire a cheaper electric rate because of what the services that we provide them. We do get
Oh,
checks.
so like, it's more advantageous for the electric company to have us as a backup.
Yeah.
If something were to happen in
Absolutely.
emergency, then
Absolutely.
it's for them to charge us for
And
our
there's only, I think, in one other plant in the entire city of Boston, it might be MIT, that has a low
MIT,
equipment.
yeah.
Yeah, MIT and Wentworth, that's it. Nowhere else in the city do they produce power.
He actually consider putting on the left side.
And there's a plaque behind that pipe that actually tells you about the cogen when it was put in, pretty much why. So we never took that plaque down. Yeah.
Okay guys, one more stop. Can you just walk to the boiler room? Boiler room and that will be it.
I'll leave. You
Walk in there.
gotta fall behind me. I don't need any stragglers.
Let me give you your yes. Juliano, no, that's not yours. Juliano.
How many what? How many plants?
This is the only true plant we have, but we do have a lot of other plants areas that have.
John, on.
We have a lot. We have a lot over there.
The other three. Christian Oliver.
He's on the phone.
On the what?
He's on the phone.
Montana. So you did get it. He just look at the solutions.
Maybe 2 or 3 pieces. Yeah.
London. Oh yeah.
Looks like everyone got cold up. Looks like everyone's getting cold up. Yeah, it depends.
Okay, you.
There are
Can they
batteries in the cogen room next to the engine. Are there Are those for? I assume this can't black start.
Okay, let's go to the board. Right, let's go to the boiler room. We're gonna see the side of the boiler also, and then we can go. Please upload your report and